So that's why we drew the micelle. We've got this whole, this thing. Alright, I'm gonna go back and show you guys a picture of glycerol again. Maybe I'll just draw it, but I think the book does a little better job than I do of throwing these things on the board.
So is that like a potential essay question, draw that and then add all the stuff into it?
Oh, myself?
Yeah.
No, just because it'll get too messy.
don't know
Even
how.
drawing a 6 myself
Mine
with
would
all
be.
these different fatty acid chains in here just gets ridiculously messy. Okay, so if we go back to glycerol, what's up here? OH, right? How polar is that?
Really polar?
Really polar, so it's gonna like the water, right? What's down here?
Same.
Polar. So if we put our fatty acid over here, right? If we're if we cross these out, then we've got our H2OH here, and our H2OH here, and our fatty acid over here. Relatively speaking, we have a pretty decent way to interface. If you look at the way that I have drawn this molecule, and that's why the book tends to prefer to draw it this way. I know a lot of times you see like this, right? But to the limited extent that my brain can do 3D, if you've got 2 OHs oriented to the right and 1 long carbon chain oriented to the left, you have an automatic picture of which ones are facing out and which one is facing in. So these ones can pop their H's off and interact with the water as much as they want, and this one is protected and dragged in. And if you have this whole chain of, and I'm not going to do the whole thing, I'll do a rainbow of 2. Okay, because I think it'll be easier, right? So you've got C1, C2, C3. So that's one of these, right? That's a head, and this is a tail. And then over here, when I take a picture, I'll remove that. That's a head, and that's a tail. So that's why I think if you're using 2D convention, it's much easier to draw it this way, because when we get to this, it makes sense. Well, how is this thing turning into a circle that interacts with the outside? That's how. Because this tail, it's hydrophobic by nature. In stereochemistry, it's going to swing as far as it can away from the polar. Like dissolves like attracts like. It's going to swing towards the ones that it's like. It's not going to go toward the polar. And if it did go toward the polar, then we start talking about nucleophilic attacks. Anybody? Okay. Alright. Well done. Okay. Okay, but does that make more sense now than
Yes.
okay, good. Alright.
No, I don't think anyone ever explained, like everyone goes, and they form my cells, and it's like, and no one actually goes way back to the beginning and goes, this just happens, it just happens naturally, and they can't get across